Let's dive into solvent extraction, a powerful chemical technique for purification. The answer? Well, it's often a surprisingly elegant chemical separation process. It's also called liquid-liquid extraction, and it works because two liquids like oil and water just don't mix. This simple tool lets chemists pull a target compound, or solute, from one layer into another. So how does the solute decide which liquid to move into? Well, that preference is measured by something called the distribution coefficient, or KD for short. A high KD means the separation is going to be efficient. A low KD, much more difficult. Let's check out a real example to see which strategy really wins out. Okay, here's our challenge. Get 4 grams of butyric acid out of 500 milliliters of water. First up, we're going to use all our extracting solvent in just one single go. And the result? We get 2.4 grams of the acid. Not bad, right? Okay, method 2. Let's split that same amount of ether into 2 smaller extractions. And wow, the total this time is 3.34 grams. That's a huge improvement. This chart just shows the difference so clearly. We got almost a full gram more. This is the aha moment of solvent extraction. The key takeaway? Repetition is power. But this goes way beyond a simple funnel. There are some really advanced techniques out there. Scientists have come up with all sorts of specialized ways to make this process even better. For example, some methods use these amazing molecular cages to grab and move specific ions. Another cool method uses a solid material to literally grab what you want as the liquid flows past. So, why does all this clever chemistry matter? Well, it's not just for the lab. It's absolutely essential for purifying medicines like antibiotics and insulin. It's a cornerstone of biochemistry. This fundamental technique is unlocking new possibilities in science every single day.